Again, I'm Scott Francis, the technical sales manager for Westex. Westex is a part of Milliken. Milliken is a big manufacturer of everything from carpets to airbags, and we're the protective fabric division. And of course, you may have heard of Westex. We make fabrics. We make flame-resistant arc-rated fabrics. We don't make the PPE. We don't make the clothing. We make the fabric that's used in a lot of the clothing and PPE out there. I'm presenting from the Chicago area, Northwest Indiana, and it's a little better than yesterday here. It's still a little hazy from the Canadian forest fires that are coming down here, and that'll be a little appropriate since we're going to talk a little bit about sustainability as well. But it looks like it's going to clear up and be a little nicer today. But as we look at the agenda here, some key things I want to talk about here, basically, is the latest edition of 70E came out. I've got the latest version here. The 2024 came out a little early, of course. And I think what's significant in terms of PPE is that the emphasis is on assessing the condition of maintenance. There's a new Annex S, as in Sam, called Assessing the Condition of Maintenance. And then also in table 130.5 C, there's some informational notes. And it talks about, assessing the condition of the equipment. As Sergio mentioned, obviously, if the equipment's not in good condition, there's, conductive dust, things of that nature, the likelihood of arc flash incident occurrence goes way up. Of course, when it's not maintained properly, but also if it's not maintained properly. And in this note here, informational note 2, in this table 130.5, it says improper or inadequate maintenance can result in increased fault clearing time of the overcurrent device, thus increasing the incident energy. Where equipment is not properly installed and maintained, PPE selection based on incident energy analysis or the PPE category method might not provide the adequate protection from the arc flash hazard. So of course, the condition of maintenance is critical to, again, reduce the likelihood of occurrence, but also, the incident energy could be higher if you're not maintaining it properly. So with the condition of maintenance of your overall program, what's the condition of your flame-resistant arc-rated clothing program? Are you in a task-based program? Maybe you need to look at a daily wear program. Maybe you're in a daily wear flame-resistant arc-rated clothing program, but it's acting like a task-based program because the garments are just too hot and too heavy and uncomfortable, and people are treating it as a task-based program, that the shirt is on the work cart or in the truck or in the locker. Again, comfort equals protection. It can't help if it's not being worn. So summertime, hot weather is a great time to evaluate flame-resistant arc-rated clothing to see if it's comfortable and that's going to actually be worn, because it's got to be worn to protect. So let's move forward here. Obviously, if you're talking about PPE, you got to start with protection. That's the number one goal. That's why, we wear it, PPE. And if I had one picture to show you why flame-resistant arc-rated clothing would be this one. It's sequential from left to right. Basically, what we're looking at here is the preventative measures put in place with the hierarchy of risk controls. The 70 cover had the hierarchy of risk controls on the old one. They dropped it for some reason on the new one. But the hierarchy of risk controls and preventative measures, like putting an electrically safe work condition, didn't happen. Maybe they had to do some diagnostic work, some troubleshooting. But the preventative measures, the left-hand side picture measures, the preventative measures were not good enough. We had an arc flash. And on the right-hand side, the protective measures were not put in place. What were we seeing there? There's arc flashes 1/10 of a second, right? There's still molten metal in the air. But what are we seeing here on the right-hand side? We're seeing the start of the ignition. It's basically a clothing fire, no PPE worn. So this is one picture I'd show is what we're trying to prevent and why flame-resistant arc-rated clothing. So again, hierarchy of risk controls, the protective measures, the risk assessment procedure shall require the preventative and protective risk control methods be implemented in accordance with the following hierarchy. So this came out in 2018. Obviously, it's still in there, the hierarchy of risk control pyramid with elimination at the top, down through engineering controls, administrative controls, and PPE is at the bottom, the last line of defense. Now, of course, elimination would be a preventative measure. Engineering controls can be a preventative or maybe a protective, can be both, a preventative and a protective measure. PPE is usually thought of as a protective measure. If you have it on, it's going to give you some protection. But I want you to think about this, and I'm going to talk further about it. Think of it as a preventative measure, and I'll talk about that a little later. Now, of course, in the 2018 version also came out was that you need to take a look at human error. The risk assessment procedure shall address the potential for human error and its negative consequences on people, processes, the work environment, and equipment. And then they had an informational note, and it called out informational Annex Q, which is called, of course, human performance and electrical safety. Excellent stuff. It obviously it's still in the latest version here, 2024. And when you talk about the hierarchy of risk controls, all of them are subject to errors in human performance. No risk control is infallible. And of course, the one at the bottom, the PPE, that's the most susceptible to human error. Are they going to don the PPE at the appropriate time? Well, let's take a look at that. Why are some reasons that employees fail to don PPE at the appropriate time? Well, one of them is, I just forgot. Well, in Annex, the Human Performance Annex, of course, it talks about all these error precursors that people are in, and it has these human performance tools that you can use to counter these error precursors. Well, I just forgot. Think about that. If let's say you're stressed, let's say you're rushed, you're frustrated, you're fatigued, that all causes people to forget. Another reason people don't don PPE is misunderstanding. I didn't know. Well, that error precursor would be lack of knowledge, lack of experience. And then, of course, one of the human precursors that are listed in there in Annex Q is complacency. Complacency, that's a safety killer. Hey, that only happens to other people. I'm not an apprentice. I know what I'm doing. I've been around for a long time. That only happens to other people. I've gone my entire career without an incident. So that's a safety killer. And of course, I mentioned time constraints. That's time pressure. That can happen, especially in today's workforce, where you have limited workers, especially skilled workers. People they got a job crunch. They got to go to the next site. They're under time pressure to get to the next job. That's why they may not don the PPE. They don't have time. They got to get to the next job. And then, of course, discomfort. It doesn't fit right. It's too hot. It's too heavy. It's uncomfortable. We'll talk about that later. It's one of the key factors where fabric manufacturers like ourselves can help in that regard. So when we talk about protection, there's two primary protective roles for flame-resistant arc-rated clothing and PPE. And I just mentioned it, FR, AR. FR, flame resistance, that's the number one role. It's got to be flame resistant for the life of the garment, life of the PPE, from day one to day 1001. It's got to self-extinguish. And there's different mechanisms, and we'll talk about that later. Most of them is, you're taking fuel out of the fire triangle, usually with your flame-resistant cotton char formers. They prevent molecules to get in the gas phase, so you're basically taking out the fuel. Some of these flame-resistant monacrylics that are being used in these blends basically throw out free radical scavengers to pair up the radicals in the fire chain reaction to terminate the fire chain reaction. So job one, self-extinguish. Insulate is job two. That's your AR. Your AR is your insulative piece. That's your arc rating. So let's say this shirt is a regular shirt, but if it was a flame resistant shirt, pretend that has an arc rating of 8.7. If this shirt had an arc rating of 8.7, I'm exposed to 8.7, that means there's a 50% chance of enough heat transfer through that fabric to cause the onset of a secondary burn. So your arc rating, your AR, is your insulative piece. That's your arc rating. Obviously, you want to pick clothing that has an arc rating higher than the incident energy. And that's why, of course, the assessing the condition of maintenance is critical, because if it's not maintained, the incident energy can be higher than you thought and maybe higher than what you're wearing currently. So two protective measure roles, self-extinguish, insulate. What about preventative roles? We're going to talk about that in a little bit. Again, the arc flash hazard, dangerous release of energy, electrical fault. You got the arc flash, you got the blast, the pressure wave, you got the molten metal coming out to meet with 70E. And then for the utilities out there, they usually want to meet with Code of Federal Regulations 1910, OSHA Reg 1910.269. Basically, the fabric has to meet ASTM F 1506, that it won't burn, melt, or drip, and that the char length is less than 5 inches when you test it by the vertical flame test. And then it has to have an arc rating when it's tested via ASTM F1959. And what we see out there in the workplace for daily wear workwear, usually for 70E, you want something that's going to give you an arc rating over 8 cals. And most of the utilities are utilizing that. And what fabrics are used? Usually you see these cotton-rich fabrics like Ultra Soft that Westex is known for, and our competitors have some of that as well. And of course, we're seeing a lot of these new lighter weight flame-resistant arc-rated blends, which we'll talk about here in a second when we talk about comfort. But why do we need to look at our program, assess the condition of maintenance, assess the condition of our program? Is our daily wear program too uncomfortable and guys aren't wearing it at the appropriate time and they're exposing themselves to arc flash while they're wearing just regular cotton? Because if they're wearing just cotton, remember, cotton is fuel. It will ignite and continue to burn.
This is cotton clothing in a Category 2 arc. However, this arc is going to do something different. It hits the ground and rolls out a good 10 feet, and the garments are instantly on fire from the shoes right on up. The entire mannequin. This is a very, very fierce fire, obviously. You're going to suffer massive, if not total, body burn.
So 8.4 cals of incident energy easily ignites the cotton workwear.
In slow motion, we're going to see the arc once again come out of the box, hit the ground, and roll out at least 10 feet. The mannequin is going to be instantly on fire, pants and shirt, from the ground right on up, clearly illustrating the fallacy of wearing non-flame resistant pants on the assumption that the arc will hit you in the chest.
So Scott, just interject here a little bit. So as electricians, we work always with our hands in front of our face.
My frame coming up shortly.
And so time and time again, when an arc flash such as this happens, it rolls up your arms, hits you in the chest, and you get a face burn without the proper protection.
Enveloping the mannequin, putting out a large amount of molten
metal. Well, that's why 7E requires,
again,
in most cases, a face shield with a balaclava to protect your face. Yeah, this is an older video. Should have head protection, certainly.
Well, certainly, but I'm just pointing out
they're not wearing clothing, so they're totally going wrong here. Yeah.
But I was saying that as electricians, we're always getting the blast in our chest. There's very few people that are out there working that get a blast in their back. So you do need to have good coveralls or good shirt and pants with protection for the heat in a blast such as this. Because stop, drop, and roll, by the time you're doing that, you've already got 2nd and 3rd degree burns without the proper protective clothing like you guys make.
No doubt about it. I mean, when you contrast, this is exactly what you don't want people doing. And then to contrast that, here, properly protected, and it's
this arc is ultra soft,
dramatically different outcome.
Category 2 arc. And as you can see, there is no fire on the garment after the arc is over. The flame-resistant clothing did its job.
And like I tell people in my classes, and
very good look here. The arc comes out of the box, wraps around to the left of the mannequin and around his back. A large amount of molten metal is thrown out as well. But once again, when the arc event is over, there is no fire on the garment.
So a situation like this is the difference between a story at lunchtime or else 3 months in the hospital, just because you got full protection.
Give us another look at the arc.
Absolutely.
Come out of the box, up the face and chest of the mannequin, and around to the left as well, and around the back. Arcs do unpredictable things. This one was at least 4 feet out of the arc gap.
So you see the incident energy, 7.4 cals per square centimeter at the surface of the mannequin there. Now that shirt is ultra soft shirt and pants. So the shirt has an arc rating of 8.7. The pants are heavier. The arc rating of the pants is 12.4. So good news for this mannequin is that the incident energy is lower than the arc rating of the shirt and the pants. So it would have done both jobs. It did job one, it's self-extinguished. But if we showed the front of a mannequin, it would look like the one on the right-hand side. The mannequin on the side, it would be charred. As you see that it formed a char to self-extinguish because that char forms so the molecules of the shirt can't get in the gas phase. So basically what you see there, it did job one, it self-extinguished. It also stayed intact. So 7.4 cals of incident energy is an 8.7 arc rated shirt. The probability of a secondary burn through the fabric, that enough heat energy is going through the fabric, would be well less than 50%. So the scenario you want is on the right-hand side. Now, what happens if you're wearing an 8 cal coverall, if you will, and the incident energy is 20 cals? what you might see is something like on the left-hand side with the coverall. You see it formed a char. It did self-extinguish. It did job one, but it didn't do job two. It didn't insulate properly to the hazard because the incident energy was way higher than the arc rating of the coverall. And of course, you get break open. And break open, I might add, in a bad spot, right? Because what's there, we all know what's there, and cotton underwear will ignite and continue to burn. So if there's enough energy left over, not to mention the molten metal coming out, can ignite the cotton, now you got a clothing fire. Not good. And this could be also a scenario when, again, if the maintenance hasn't been done, the overcurrent device the maintenance hasn't been done on that, the clearing time can be longer clearing time because it has been maintained, higher incident energy. You might be in a situation on the left-hand side. So again, the importance of assessing the condition of equipment is kind of critical. And I know Sergio was bringing that up as well. So moving along here, how do you monitor this? How do you change this? Don't wear an 8 cal coverall to a 20 cal arc. Assess the condition of maintenance, make sure it's maintained properly. But also layering might be a good idea. And there's a lot of base layers out there, lightweight base layers that have low arc ratings, but they wick moisture, that are comfortable. And just for instance here, usually the arc rating of a layered system is usually more. It's usually more than additive because you got that air gap, okay? So like if you had two ultra soft shirts, 8.7 versus over 8.7, it's more than additive. Actually, the arc rating, the layered arc rating is 26.8. And you see, most of these are going to be more than additive. Now, you can't just add them. These need to be determined experimentally in the lab, at Kinetrics to determine the arc rating, because not every time you get something where that it's more than additive. Sometimes it can be less than that, especially if you have like a heavy outer layer and a real lightweight inner layer. You can have an arc rating at much lower than you might think. So again, where do you get that information? Get it from fabric manufacturers like Westex or our competitors, TechaSafe and Glenguard. Or if you're using multiple fabrics, your service provider like a Tyndale or whoever supplied you the garments might be able to provide you with layered arc rating data. I know Tyndale has a lot of information out there because they handle a lot of the utilities. So there's two types of arc rating. You see that in the label. It's usually an ATPV, arc thermal performance value, but there's another type of arc rating that you may or may not have seen. It's called an EBT, energy to break open threshold. They're both arc ratings. One's not better than the other. Obviously, you want to have that number be higher than the incident energy that you're exposed to, of course. But again, your ATPV arc thermal performance value is the incident energy that results in a 50% probability that sufficient heat transfer through the fabric is predicted to cause the onset of a secondary burn through the fabric based on the Stoll curve. And typically, when we're talking about woven fabrics, they tend to be a little stronger. That's where we get ATPVs. Where we see E sub BT, energy to break open thresholds, again, that's the energy where you didn't get a secondary burn through the fabric, but the fabric broke open half a square inch. You report that value, that 50% probability of break open of a half a square inch. It didn't cause the sensor in the test method to cause a secondary burn, but it broke open. So that's what you report. And you see the E sub BT is usually for your knit fabrics, because they tend to be more insulative and they trap more energy and then they can break open before they cause a secondary burn. So one's not better than the other. Obviously, you want that number to be higher than what you're exposed to. Okay, and where do you find that? Obviously, Wrangler FR pant. That looks like it's my pant, 4232, not good, working on that, but yeah, it has an arc rating of 17 ATPV. You see it on the right-hand side of the picture on the left, and then, of course, older work right shirt had an arc rating of 8.7. Usually they're in the nape of the neck, or actually more of the garments I'm seeing out there now, they're down towards the bottom of the shirt, inside the shirt towards the bottom will have an arc rating. And again, a lot of the labeling out there, we're seeing better labeling out there. Like here's a Rasco shirt made from Westex DH Air. You see the component is our fabric there, Westex DH Air, and it's a Cat 2. You see, it says Cat 2, so we know the arc rating is greater than 8. Inside the garment, it's going to show that the garment has an arc rating of 9.1. And then what's that 2112 mean? You'll see that on a lot of garments. 2112 means that it meets NFPA 2112, which is for flash fire. So if you have an environment where you're working around chemicals, like maybe you're doing electrical work in a refinery or a chemical plant, you probably want flame resistant arc rated garments that also meet NFPA 2112. So let's take a look at comfort.
And this just Scott, I'll interject here for a sec. Here,
sure can.
One question that people are asking right now is, and I think it's important that you bring it up right now. Does Westex do their own testing?
Well, we have it's tested at Kinetrix for arc rating, all that stuff done. And then of course for NFPA 2112 certification, it's third-party certified, UL certified for flash fire.
And that's what I'm saying is that the cloth, when it's made, is tested by a third party. So the arc flash rating that people see on their clothing is not just put together by Westex, but a third party tests that cloth and certifies that it's good for whatever arc rating it is. So that's why quite often you would see, one shirt in this year, if I bought it, might be 9.2, and next year if I buy it, it might be 9.6. It's just a tiny bit difference in the testing rating. But we have Arc Safe in Louisville, Kentucky for the U.S. and Kinetrix Lab in Canada doing the testing, and then for the Westex fabrics, and then you build according to those.
Yeah. I mean, for arc flash, you don't necessarily have to have third-party certification. You don't have to. There's 3 different conformity that you need to go through. But for flash fire, you typically need third-party UL certification. But most of the fabrics for arc flash is a component. It's a fabric test, and most of the testing is done up in Toronto at Kinetrix to determine the arc rating of the fabrics. And then, of course, the garment manufacturers put it in their label.
Thank you, Scott.
So, okay, moving along here to innovative flame-resistant arc-rated fabrics. Again, why are we concerned about this? Because when you take a look at reasons why workers fail to don PPE at the appropriate time, sometimes it comes up, hey, it's just not comfortable. It's too hot. It's too heavy. I'm going to have heat stress. I can't wear it. Well, let's take a look at that. Let's take a look at comfort. Comfort is subjective. When you talk about weight, when you're talking about different types of fabrics, synthetics versus natural fibers like cotton-rich, flame-resistant fabrics are always going to be a little heavier. They have to be a little heavier for durability purposes. So when you're talking about weight, if you're talking about different types of fabrics, it's really not a factor. But when you're talking cottons versus cottons, usually the lighter weight fabrics are going to be more comfortable, if you will. Again, comfort subjective. The best way to determine comfort is to do a wear test. Now, again, clothing is very personal. You're not going to get everyone to agree on one fabric or one type of garment, but you will certainly be able to develop a consensus on what fabrics and what kind of garment designs are going to work for you. And if you think about it, doing a wear test is also a great opportunity for employee engagement. So what I would recommend is when you are going to do a wear test, and usually the summer is a good time to do that, is engage the floor or field safety leader. Maybe they don't have safety in their title, but it's a person that's on the floor that takes safety personally, and the people in the workforce respect that person. Get that person involved in the wear test, because if that person buys into it, guess what? The rank and file are going to follow suit because that person's respected. So great opportunity for employee engagement. Again, comfort subjective, but you will be able to develop some kind of consensus. There are some tests that we can look at that might help, but really there's no substitute for a wear test. So remember, comfort subjective, heat stress. So that example, excuse, hey, I can't put this on, I'm going to have heat stress. Well, if you're talking about flame resistant arc rated clothing, per OSHA, no single layer, breathable, woven or knit fabric, whether it's flame resistant or not, causes heat illness. So if it's got some air perm, it's single layer, it's not causing heat stress. What causes heat stress is poor hydration, lack of rest breaks, lack of shade, poor health. Actually, I was at a conference, a VPPA conference last year, about this time of year. Hot. It was in Alabama. Hot. And I was in the hotel room, and I was up on the upper floor, and I looked across the way, and the people were doing roof work, and it was boiling out there. But they were all wearing light colored shirts, long sleeve. They had, sun hats, if you will. They were all covered because, again, it was breathable. It basically acts as shade. If it's got some air perm, it's one layer. It's going to act as shade. It's going to breathe, and it's actually going to cut down the sun's radiant load. So don't confuse heat stress and comfort. They're two different things. So why are these fabrics, so people don't wear it. It's not from heat stress. It may be a comfort issue. Comfort's critical because comfort equals protection. That flame resistant arc rated shirt does no good if it sits in the truck or in the locker or on the work cart. So we want to look at two things at the top of the list: comfort and protection. And again, when we look at comfort, we want to talk about breathability, moisture management, soft feel, lightweight. Those are typically the things we look at. But we usually need to have for arc flash, we got to have a bar here. And usually what we see for daily, it's got to be at least Cat 2, because you're not going to buy something Cat 1. It may be lighter, but it's not going to get the job done, because you want something that's Cat 2. Then if you go higher, you can go with task-based gear, if you will. So again, look for protection, something with arc rating greater than 8. Go with something that 2112 certified. More and more of the fabrics out there today are dual hazard because it meets more markets. And you may be doing some work in a place where they have some solvents or combustible dust where you might need the 2112 certification. And of course, is it going to hold up? We'll talk about that. What about shrinkage control? Value, that's a key thing. And that will be linked to sustainability, which I'll talk about here in a second. And of course, appearance, and then of course confidence. Do they trust that the PPE is going to work at the moment of truth? So what are the latest fabrics that we see out there? Are these blends? A lot of Westex for years and years, and we still offer our ultra soft. It's cotton rich. It's an excellent product. A lot of people like it, but it's since it's cotton rich, it tends to be a little heavier than some of these new lightweight blends. They seem to be lighter. People really seem to like them. They're usually blends. They've got high air perm, and they tend to wick moisture better. So those are some of the brands that we make at Westex as a part of Milliken. Our Westex DH for dual hazard, and DH dual hazard and air because it's lightweight. And of course, Milliken also owns Polartec, and Polartec makes knits and fleeces that are flame resistant as well. And they make sports gear as well, the Polartec brand you may have heard of. And then some of our competitors, obviously, they're making us better. They've got some good stuff, lightweight blends as well. Glenguard is a fabric that you see out there quite a bit. And then Tenkate is a competitor of ours. They have a nice product called TechaSafe One. And then, of course, Carhartt has an exclusive to this Arvine fabric, which I believe is from India. It's the Carhartt FR Force, which is lightweight. So let's take a look at some of these. The DH Air, and a lot of these are blends, and they're similar blends. They're slightly different. But the DH Air is basically 47% Tencel lyocell, which is from trees. It's cellulose. It's not even flame resistant, which is okay because it's in a blend that is flame resistant. The 38% is flame resistant monacrylic, and then the 15% aramid, the para aramid, which is like Kevlar, if you will. So they're flame resistant. The flame resistant monacrylic, it of course throws out the free radical scavengers to pair up the radicals of the fire chain reaction to terminate the fire chain reaction. Aramids, of course, are thermally stable. So that's the blend. A lot of the competitors are similar to that. You see our blend there. The TechaSafe One is very similar. It's got a similar blend, if you will. The Glenguard is slightly different, but you see a lot of them use monacrylic. The Arvine Carhartt FR Force is using a lensing product, which is like, it's again from wood. It's a cellulose, but it's made flame resistant in the fiber forming process. So all these are inherently FR. Again, these blends, what do they bring to the table? Better air perm. They wick moisture better. And again, they meet the bar that they're over 8 calories per square centimeter for arc rating. So they meet PPE category 2, and all of them are dual hazard, meeting NFPA 2112 for flash fire. So these are ones that we're seeing out there that are starting to become very popular, again, because they're comfortable, they wick moisture, they have high air perm, and they're guaranteed flame resistant for the life of the fabric. Some of the things to maybe consider for comfort, again, the punch weight of the fabric. Usually the lower weight fabrics are better. So you want to go with the lighter weight fabrics. The the Westex DH Air is 5.5 ounces per square yard. So here's some other brands, but again, you look at lower punch weight, air perm, you want that to be higher. The water drop test, you want that to be a very low number in seconds, because that means it spreads the drop in a timely fashion. So a lower number is good for time. And then of course, usually the higher percentage of cellulosic fibers from wood, usually it seems to give more comfort because it has the air perm and it wicks the moisture better. So again, these are some things to look at, but again, for comfort, really, there's no substitute for doing a wear test. A wear test is the best way to determine. Now, let's take a look at sustainability. It's kind of a big word we're hearing a lot in industry, of course, with the forest fires in Canada. Obviously, the environmental concerns, sustainability is becoming an issue here. So when you talk about flame-resistant arc-rated fabrics, some key questions to ask yourself is, what are the materials? What are the fibers that are making this up? Are they durable? Are they comfortable? Are these fibers, are they utilizing renewable and recycled sources? Because if they are, they're more sustainable. What about the manufacturing processes of the fabric manufacturer and the garment manufacturer? What are they doing about greenhouse gas emissions? Are they committed to get to net zero? Again, that's becoming more and more of an issue, and we'll talk about that. And then, of course, fabric finishes and certifications. What about PFAS, polyfluoroalkyl substances, a forever chemical that's getting a lot of ink in the paper, if you will. The PFAS is not used to make anything flame resistant, but it's used for wind and water repellent. So a lot of the outerwear that's flame resistant also may have PFAS to cut down the wind and offer water repellency. So we're moving away from that. So those are the three things to look at. Now, what's the most sustainable flame resistant arc rated garment out there? What is the one that's the most sustainable? Well, it's the one that's in your closet, that's durable, and that gets play, that's out there being worked because it's comfortable. So it's got to be durable and comfortable. That's the most sustainable garment. Now, if it's durable, but it's uncomfortable, it's going to sit in that closet for a while, and then finally the person's going to ditch it unless they're a hoarder, right? So it's got to be comfortable and durable, because durability is at the heart of sustainability. So that's the number one thing. So now, can we use some recycled materials to make that? Well, yes, Reprieve is being used in a lot of different products. It's also being used in some of our denim. I'm sure more products are going to follow. It's in there to give strength to the denim. It's in the blend. It's usually like 6 or 7% in the denim fabric, but it's from recycled bottles. And again, if you're using recycled content, you're not using new chemical feedstocks, more environmentally friendly. What about renewable? What about wood? Cellulose. That's why more and more companies like ourselves and our competitors are using this Lenzing Tencel lyocell. It's from wood. It's from cellulose. It's more renewable. They have a great story on how they reuse their solvents to make the cellulosic fiber. So again, it's a sustainable product from wood. Now, the second bucket is looking at the path to net zero. This is becoming more and more of an issue. And again, what we're going to see more and more as more companies become involved. And again, this is all involved with the Climate Paris Agreement, trying to keep the temperature below 1.5 degrees Celsius by 2050. And the Science Based Target Initiative is basically a third party that comes in and approves your goals and monitors your progress to your goals. So take a look at this net zero a little closer. There's really 3 scopes when we talk about emissions. Scope 1 are emissions that you generate at your facilities, at your factories, what you generate. And you can control that. And that's easier to control. Scope 2, you're not generating the emissions on site. They're being generated by the power you consume. So it's by the utility that you buy electricity from. They generate emissions, and that can be determined. So scope 1 and 2 are relatively easy to determine. Scope 3 is the bigger amount. That's the huge amount, and it's harder to get your arms around. And that's where it gets everybody involved, because it's emissions from upstream and downstream operations across your supply chain. So if you're making a component, like we make fabric, our customers, our scope 1 and scope 2 for that particular product, as well as our downstream scope 3, are our customers' scope 3 upstream. So that scope 3 is a big thing because it gets everyone involved. Now, is Westex, is a part of Milliken, are we at the point where we can say it's X number of pounds of greenhouse gas or CO2 per yard of fabric? No, we're not there yet, but we're going to get there. So that will help us to determine, or help our customers determine what our impact to their scope 3 by telling them it's, X number of pounds of CO2 per yard of fabric. We're not there yet. We're working to that end. So again, how do we do that? How do we help our greenhouse gas emissions? How do we reduce that? Well, if you do cogen, you're using gas instead of coal. You're using the heat that you generate in your processes to make steam to generate electricity. What does that do through cogen? You're cutting down your scope 2 greenhouse gas emissions because you're not having to buy as much from the utility because you're generating in the house. So that's one way to look at it. Manufacturing processes. Westex is a part of Milliken. Milliken has near-term targets that have been approved by SBTI, and we're reducing our scope 1 and scope 2 greenhouse gas emissions by 50% by 2030, which is only 7 years away. And then we've committed reducing our scope 3 greenhouse gas emissions by 30% by 2030. And then, of course, our long-term goals, 2050, is we're trying to get to net zero. Now, right now, we're looking at 1, 2, and 3 greenhouse gas emissions by 90% by 2050. So we got 10% to go. We're hoping to get there. It'll probably be more something on the last 10% will probably be a carbon capture or something along those lines. But again, short-term goals, near-term goals, the manufacturer of the fabric, of the garments, are they moving forward with this? Something to look at, and it's going to get more and more involved, and you're going to see more requests for it as more companies get involved because the scope 3 gets everybody involved along the supply chain. So lastly, this PFAS, polyfluoroalkyl substances, forever chemicals used for wind and water barrier, not used for FR, but Okotex 100 certification, the standard 100, to get that, you can't use PFAS. If you're using PFAS, you can't get the Okotex standard 100. So that certification is kind of important because it signifies that you're using products that have been tested and found to contain no harmful substances. So PFAS, if you're using that, you can't get that certification. We've moved away from it. Effective Jan 1 of this year, we no longer make fabrics that utilize PFAS chemistries. So in summary on the sustainability piece, again, what's the most sustainable flame-resistant arc-rated garment you have out there? The one that's durable and comfortable because it's in play and it's going to not get to the landfill quickly. And then secondly, look at the greenhouse gas emissions because that scope 3 is going to get everybody involved. And of course, you don't want to have to deal with PFAS because it's a forever chemical linked to cancer and very, very, very low concentrations. So again, work with credible, eco-friendly, flame-resistant fabric and clothing manufacturers to help your overall sustainability goals as a customer. So to wrap up here, I think I got about a few minutes here, and then we can take some questions. But let's look at trust. Are the PPE best practices that you have in play, do you trust that they're being utilized? Are you in a task-based program, or are you in a daily wear program? Or is your daily wear program not working out because the fabrics are too hot, too heavy, the clothing's uncomfortable, and it's turning your daily wear program into a task-based program where they're not wearing it. They may don it on occasion, but they're not. And again, for the clothing, for the body protection, these are the two types of programs we look at. And how do we determine that? Is we need to look at the risk management, risk assessment, and of course, safety professionals. Engineering types are great at doing risk assessment. Of course, the risk, what are the hazards? In this case, we're talking about arc flash. What are the consequences? Well, it can be catastrophic, especially if you're wearing fuel. If you're not wearing the PPE at the appropriate time, garment ignition, catastrophic burn injuries. And then let's look at the likelihood of consequences. And of course, we want to reduce our risk to as low as reasonably practicable. Not practical, practicable. And really, if you think about daily wear, it's a reasonably practicable practice to do that. So what about the likelihood of consequences? Okay. Number one, for PPE, how am I going to determine if I'm going to daily wear or a task-based? Well, first, number one, the person's got to be qualified. If they're unqualified, obviously that's not good. And the likelihood of incident occurrence goes way up. So if they're not qualified, they're not getting any PPE because guess what? They're not working on this job. They're not qualified. Now, let's say they're qualified. They're qualified, but what state are they in? Are they rushed? Are they showing that they're rushed because we got a tight workforce? Are they fatigued because we got a tight workforce? Are they stressed? Are they showing signs of complacency because they think they know what they're doing all the time and maybe they don't? If they're showing some signs there, how do we counter the consequences of stress, of fatigue, of complacency? Well, a good way to do that would be to go with a daily wear program because it's going to counter the consequences of human error, these human error precursors like complacency, like rushing, like frustration, like fatigue. So that's number 2. And then of course, number 3, history and current status of equipment kind of, again, leads in to assessing the condition of the equipment. Again, we need to maintain it. If it's been not maintained or we're not sure where we're going all the time, that really makes a case for a daily wear because you're not sure what you're going to get into. Now, in my view, a task-based program where you don PPE at the appropriate time, the best case for that would be like a new construction. It's all de-energized. It's pulling wire through conduit, right? You don't need to have PPE. Everything's de-energized. And then you need the PPE, the task-based PPE to don when you commission it, when you fire it up. That makes sense for a task-based program. But again, history and current status, again, with the changes in 70E, the Annex S, assessing condition of maintenance, that's key. And in the notes that I my intro with, and of course, again, with assessing the condition of equipment, NFPA 70B, B as in boy, of course, was a recommendation. Early this year, it became a standard. So again, I know the emphasis is on number 3 here is I think it's really critical that we maintain our equipment because if we don't, we may be having people being exposed to incident energies higher than they once thought, as I mentioned in my opening comments. So let's talk about routine task and complacency because we see, anecdotal incidents occurring with either newbies, brand new people, but we do see it even with more experienced ones. And you see that in some other like high adrenaline sports as well, like skydiving. And what we see is usually the newbies, it's, lack of knowledge, lack of experience. But what's happening with the more experienced ones, not the way experienced ones? The way experienced ones, hey, that's why they've been around for so long because they know what they're doing and they don't take chances. They put the PPE on. But when we're talking about more experience, some of these cowboys, if you will, they think they know enough and they can become complacent. And it usually happens with the routine PPE category 1 and 2 type tasks. It's relatively lower energy on 480 volt panel boards. If it's a category 4 PPE category 4 type task, usually most of the electricians are going to say, hey, time out. I'm going to go get the stuff. This is high energy. But if it's routine, it's a cat 1, they may be apt to say, it's at the end of the day, I want to get going. It's not going to take long. There's low probability there's going to be something happening. And then they do something, and then they have an incident and they're wearing fuel. Not good. And so this complacency can really set in, especially for these routine low energy tasks. And that leads to the normalization of deviance, which is the gradual process through which unacceptable practices and standards become acceptable. As the deviant behavior is repeated without catastrophic results, it becomes the social norm of the organization. You need to avoid this at all costs. Once you get this, it's hard to overturn this. So you need to nip this normalization of deviance in the bud because it's tough to overcome. So again, complacency can be a killer, and it's usually the root cause of a lot of these electrical incidents at 480 and below. 480 is considered low voltage, but it's a leading killer out there. So I really want you to think of flame-resistant, arc-rated daily wear clothing. Think of it as a seatbelt. Think about it. From a protective measures standpoint, the logic's the same. If you have your seatbelt on, if you're wearing your flame-resistant, arc-rated clothing, if there's an incident, car crash or an arc flash, you're going to have some level of protection, which is good news because even if you're a great defensive driver or you're an excellent electrician, some things can happen that out of your control. You're driving along, you're a defensive driver, but if someone goes across that line, you're going to be in an accident. Or you're working on something, you open it up, someone else left a tool in equipment and it causes an arc flash. So if you wear it as a protective measure, just like wearing a seatbelt, you're going to have some measure of protection. Well, let's say the seatbelt analogy really doesn't work for a task-based program. So let's do my seatbelt analogy for task-based. Let's say I'm just going to go down the street, a few blocks away to the convenience store to pick up milk for the kids for breakfast. So it's a short trip. I'm not going to wear the seatbelt. It's real quick. I'm on my way. Nothing should happen. But some guy that's been out all night drinking goes across that center line and hits you. It's too late to don that seatbelt. Just like when you're doing a routine task at the end of the day. You don't have time to don the coverall because you want to get going home. You open that, someone that left that tool, you have an arc flash, now you're exposed, you're wearing fuel. Not good. So task-based PPE does not work in the seatbelt analogy as a protective measure. Now, what about PPE as a preventative measure? Let's take a look at this now. Preventative measure. If I'm wearing flame-resistant arc-rated clothing, shirt and pants, it's a constant, proximate, tactile trigger, if you will, to access the appropriate mindset to access my electrical safe work practices training. Especially when you're about to work on something, you're wearing a long sleeve, flame resistant arc rated shirt, you extend that, not only do you feel it, but you see it. Oh, I'm about to work on energized, I'm wearing this special shirt. I should probably put voltage rated gloves over my flame resistant arc rated shirt sleeve. Oh, I should probably put task-based headgear, face shield, balaclava, and then go to work. So again, flame resistant daily wear, just like a seatbelt, even more than a seatbelt, is a constant, proximate, tactile reminder to access, or a trigger, if you will, to trigger, hey, I got to be in the right mindset to work here. I should probably put other PPE on, follow your electrical safe work practice. So that's how I see flame resistant arc rated daily wear. Not only is it a protective measure because it self-extinguishes, it insulates for your protective, but it also acts as a preventative measure because it acts as a trigger. So don't let this happen to your organization where they don't don the PPE at the appropriate time. Whoa, sorry about that. The wrong one. Here we go. This is at a bank down in Florida. You may have seen this video. Two guys come out. The first guy's not burned yet. This guy's on fire. Not good. The front of his shirt's on fire. This is at a bank. What do they got? HVAC, certainly. He's on fire. Was the PPE in the truck? I don't know. Doubtful. The guy was wearing shorts. They probably didn't have any PPE. But the first guy that comes out, he's not burned, but he ends up burning his hands because he's patting out his colleague. Not good. So if you're in a scenario, here's a daily wear situation, shirt and pants. Here's an arc flash. Here's the arc. The clothing didn't ignite. Self-extinguished. Looks like there's no really break open, so it did job one. It's self-extinguished. Looks like it insulated properly to the hazard. So we would say, probability of no burn through the fabric. Looks like the fabric's in good shape. Looks like these guys can, go back to work right away. But probably after an incident like that, they probably got to go home and do some laundry, if you know what I mean. So with that, I think we've got 5 minutes or so for questions. Again, I appreciate your time and what you do for the industry to keep America's electricians safe. Thank you.
Thank you so much for that, Scott. I got a whole whack of questions for you here. Go back to your chat box here. So if you go back up here, let's see. Let's go right back to. So in terms of those videos, I said the Westex sites, you do have a lot of the videos on the Westex site if people want to see these videos that you showed. Is that correct?
Sure. Yeah. Go to westex.com and you can access. I think we might, request some information from you to have access from it, but I think it's pretty straightforward and shouldn't be a problem. Again, people respond to video. People are visual. Yeah. You can talk about it, but when they visualize it, it makes a difference. So great for hazard awareness training. Here's why you can't wear cotton, because it will continue to burn and cause catastrophic burn injuries. So again, feel free to use them. That's what they're there for. And
I can't say enough. I've been a trainer for almost 35 years. I started back in 1985, believe it or not, with the NFP 70E within our organization. Indeed, we became one of the first companies in Canada to adopt the 70E standards, which became CSA Z462, of course, in 2009. But right. One of the big discussions all the time is my underwear. What should I wear as underwear when I'm wearing this kind of clothing? And Ruben Knight has asked that. What should our undergarments be made of?
Well, okay, that good question. Now there are more options out there than ever for flame-resistant arc-rated base layers, which I think wick moisture and they're flame-resistant arc-rated. They the arc ratings are usually like 4 cals or something like that, designed to be worn over flame resistant, underneath flame resistant arc rated outer layers. So those would be a good option. Other than that, obviously you want to stay with natural fibers, cotton, wool. Hey, there's your opportunity to wear silk underwear, right? That's a natural fiber. Now, of course, natural fiber, it gives you some insulation. It will protect you as long as that outer layer, that outer flame resistant arc rated layer is not compromised. If it's compromised because the incident energy was much higher, it could break open. And if there's enough energy left over, not to mention the molten metals, the molten metal coming out, that could ignite the natural fiber clothing. So my recommendation is look at these base layers that are flame resistant arc rated, because they're going to add for comfort. They're going to wick moisture away, and they add additional protection, which of course, as I opened up with, people are stretched thin, right? The workforce is tight. People are rushed. Is all the maintenance being done? Sometimes this equipment may not be maintained properly. The circuit breakers, the overcurrent devices may not be working like they should. Longer clearing times equal higher incident energy. You might want to look at a base layer, not only for comfort, but added protection.
Right. And another thing too is that a lot of ladies, and when I started teaching years ago, one of the common complaints from the ladies was that the clothing didn't fit them well because it was predominantly made for the men's workwear world. But now we have lots and lots of different options made for ladies. Design consultants have been brought in, so it's quite fashionable now. But along with that too, for ladies, for bras, and I've, personally, I've had to, go on side with the ladies for some of the companies, because a lot of the ladies that are electricians and technologists working in systems end up wearing some sort of sports bras, which have high spandex content.
Yeah.
And there are bras out there that are not so much arc rated, but at least flame resistant. Yeah.
Or they could, a remedy. I mean, I think there's more options for that. But another option would be go with a silk bra, and then maybe put a flame resistant arc rated base layer over that, and then your flame resistant arc rated shirts. You'd have, roughly 3 layers there. But you want to, obviously you don't want any synthetics in there.
So next question is, gee whiz, I've had my coveralls here for 3 years now, and I usually wash them once a week. How long are they good for?
Well, again, you want to go with a fabric manufacturer that you trust. PPE is about trust. Do they guarantee the flame resistance for the life of the garment? And usually there's a caveat with that from the fabric manufacturer, that it has to be cared for and maintained, laundered properly. And they're all in the labels of the garments. Avoid chlorine bleach, avoid fabric softeners. Those are the 2 big no-nos. Chlorine bleach, usually for your cotton-rich fabrics, the chlorine bleach, repeated use will break down that polymer that's in the core of the cotton fiber. So you want to avoid chlorine bleach. Again, these are colored. Most of these are colored garments, so they're not white, right? We usually discourage people from using white flame resistant garments because they might be tempted to bleach it. So that's one. And the fabric softeners, the risk there is that those have flammable components, so they can build up over time. So it's like, in essence, rubbing oils and greases in the garment. Now, again, one time, not a big issue, but if you repeated use, it can build up on the garment, and those are flammable. So the remedy for that is just stop using the fabric softeners. They're going to wash out. You don't have to ditch the garment. Just avoid using the fabric softeners. And again, another thing is, down in Texas, I hear they like to starch their flame resistant denim jeans. That's not good. No starch. So, you don't have to ditch the garment. Just stop using the starch. It'll wash out. So again, when to replace them, if it's guaranteed and you've been following the maintenance and care instructions properly, you should be good to go. If you get a lot of fraying and they're really threadbare, that would probably be time to turn them in. But if they're in good shape and you maintain them properly, and it's from a fabric manufacturer that guarantees the flame resistance for the life of the garment, you're good to go. And they are tested up to 200 washings in the initial program, aren't they? Well, here's the deal. To be NFPA 2112 certified, the fabric has to be flame resistant through 100 washings, and it has certain conditions. So the Westex fabrics go beyond that. It meets NFPA 2112, but we go beyond that. We say it's guaranteed for the life of the garment. Again, with the caveat being that you're caring for it properly. No chlorine bleach, no starch, no fabric softeners. There's a list there on the garment. But if it's maintained properly, and it's not, threadbare and, or frayed, you're good to go. Actually, we did some testing with Ultrasoft because the question came up, hey, you're losing cotton fabric, in the dryer, right? You got that lint. So I'm losing mass, right? So is my arc rating going down because I'm losing mass? Well, we tested the Ultrasoft cotton-rich fabric after 100 washings, and the arc rating actually was a little better. Now, how could that be? You are losing mass, you are losing some cotton, but what does cotton like to do over time? It progressively shrinks. So your ounces per square yard basically stays the same. So the arc rating actually stayed roughly the same, and actually in some cases was a little better because of that progressive shrinkage, countered the loss of cotton in the, as in the form of lint in the dryer. So to answer your question, again, if it's guaranteed FR by the fabric manufacturer, you trust it, you've cared for it properly, it's in good shape, you're good to go.
Right now, I've got Nala Cannon has asked a question. Could you look up on your chat box there? Please advise 99% cotton, 1% anti-static. And then after that, I sort of lose it. I'm not quite sure what exactly the standard there is. Is that a standard that you use there?
I don't see where you're talking about here.
It's in the chat box from Nalia Cannon. Says, oh, to me direct. That's why. Sorry.
Okay.
I'll forward this to you right now.
Okay.
Hi, can I talk to you?
Oh, sure. Go ahead.
I don't see it.
No, I'll send it to you right now to, I'll just put it out there for everyone. So here's the question.
Okay. Okay. These are ISO standards. I see those look like for molten metal possibly, and some other things here, but it has ASTM F1959. That's your arc rating, and it looks like it's 9.1 cals per square centimeter. So that ASTM F1959 says that that's the test method, which is the correct test method to test for arc rating, and that the arc rating is 9.1 calories per square centimeter. So that's good. That means it's arc rated. And then those ISO and ISO standards, they're going to have some different parameters for flame resistance on there. Again, I don't know what those are offhand in terms of the parameters, but looks like it's pretty good. Our fabrics meet some of those as well. I just don't know the exact criteria. I can certainly look that up for flame resistance and how many washings it goes through, but it is arc rated. Again, I would go and find out, and I can help you with that because I'm familiar with those standards to some degree. I just don't know what it is offhand, what the number of washes is for flame resistant durability on that. But I would go beyond that and say, hey, the fabric manufacturer, are they guaranteeing the flame resistance for the life of the garment, provided that the care and maintenance has been followed?
Does that answer your question, Nalia?
Yeah, this is Kanan from Loyal Textile. That number of washes is 50 washes we want.
I'm sorry, say it again.
So my question is, we want 50 washes, but 99 cotton, 1 anti-static will meet that 9.1 cal per centimeter.
Okay, so it's 99% cotton, 1% anti-stat. Okay, yeah, the anti-stat. Okay, the 1% anti-stat. You need to have that in there to pass those NISO standards, because they're going to require that, because our fabrics for Europe have to have anti-stat in there. So that's probably what that's about. The 100% cotton is what you're saying. It should be in 100% FR cotton, right? Because it's got an arc rating. It's flame resistant. Now, again, I don't know how many washings that's guaranteed up to. I'd have to look at that standard again, but you want to ask whoever's making the garment or the fabric manufacturer, what is the guarantee of FR? But that 1% anti-stat is probably used to meet the NISO standard, and why they have that in there. And usually for cotton, you don't need it in regular humidity ranges. But if you get in a situation where it's very, very dry, very low humidity, you might generate a spark. So that's why they have that 1% static dissipative requirement, because that you don't want to create static, because that could be a spark that causes a flash fire. If you have the vapor and you create a spark, it's a potential ignition source. That's what that's the reason why that 1% is in there. But that 100% or the 99% FR cotton, again, the manufacturer, that would be someone you'd want to talk to. If it's Westex, we guarantee it. Yeah, but I'm not sure who the fabric manufacturer is for this garment.
Okay, so looking at hood ratings, like why do we wear hoods under? Why is it recommended we wear hoods under our hard hats, Scott?
Well,
and what kind of hoods do you have?
Yeah, usually usually what they call out is what a balaclava, not to be confused with baklava, which in Chicago we got a lot of Greeks. It's a great Greek dessert. It's a balaclava, which is like those race car driver hoods with the opening in the face. And again, it gives you 360 degrees protection. That coupled with the hard hat and face shield, you're good to go. Now you don't have to wear that if you're using like a hood with a face shield. You don't have to use the balaclava, but I think for your PPE Cat 2 in the standard, it calls out the use of a balaclava if you're using
and they come in 4, 8, 12, and 20 calorie standards. So depending what kind of work you're doing, if you're doing a lot of inside work, the 8 calories is usually plenty, just protecting your chin and your back of your head. So another thing is, one question is differentiate reduction and flame reduction, like FR to ATPV reduction. Is there a difference between the two after, let's say, 50 washings or 100 washings?
Okay, well, yeah, as I mentioned, there's 2 roles of flame resistant arc rated clothing. Job 1 is FR, flame resistance. That's the job 1. That's the most important, because if it doesn't self-extinguish, if it's on fire because it's lost the flame resistance washed out because it was a shoddy product, if the fabric burns, who cares what the arc rating is, right? So job 1 is the FR, and that's you got to make sure it's guaranteed for the life of the garment that it's going to self-extinguish throughout the garment's lifetime. And then job 2 is your insulative piece. That's your arc rating. And as I mentioned before, we did some testing on arc rating after 100 washes with Ultrasoft, and we found that the arc rating was as good, if not better, because you got progressive shrinkage. So your ounces per square yard of the fabric was roughly the same, even though you're losing some mass. So I think I addressed both of those. So they're 2 separate items. And it gets a little confusing sometimes. Hey, what's the difference between FR, AR? I like to use the term flame resistant arc rated, because all arc rated clothing is flame resistant, but not all flame resistant clothing has an arc rating. So the term I like to use, and you see more and more of that being used, is it's FR/AR, FR/AR or FR arc rated clothing, because I like it because it tells the 2 jobs. Job 1, FR, flame resistant, self-extinguish. Job 2, AR, arc rating, insulative piece.
Okay. And just gloves being part of the total package, of course, our gloves have ratings of anywhere from 15 to 25 calories or higher, of course, depending on what level we're working with. So the gloves being a part of the whole package, it's not part of Westex's world, but we have to have the gloves on to give us full protection.
With the leather protectors, of course.
Yeah.
It even adds more. So great. Yeah.
Okay. Well, thank you so much for that.